Alright, I'm going to go over a little bit of one of the problems on the worksheet, number 3, just to show you how these Newton's laws equations and the kinematics equations all go together. So, if you look at this, it says a girl in a canoe uses a paddle to push the canoe from rest, so remember what that means, giving it a speed of 0.3 meters per second, so you've got VI and you've got VF, and the paddle's in contact with the dock for 0.75 seconds, and it wants to know the force, and of course it gives me then two masses, the mass of the canoe and the mass of the girl. So, looking at this, if we're going to draw our free body diagram, the girl pushes, obviously she's got her weight, and then there's the force of the water pushing up on the boat. That's what keeps it there. We'll call it a buoyant force, but we don't have to worry about it. And then she pushes with some force that she applies. Now, we don't know what that force is. That's what the question's asking us. But it tells us that our initial velocity is 0 meters per second, and our final velocity is 0.30 meters per second, and it tells us that the time is 0.75 seconds, and the mass of the boat is 27 kilograms, and the mass of the girl is 52 kilograms. So this is all the information that they give us, and what we don't know is the force. But in order to find the force, we know that these two forces cancel out, so when you're trying to find that force, the unbalanced force, in order to find the force, we know we have to have the acceleration. So this is where you use the kinematics equations and Newton's laws together, because in order to find acceleration, or force, in order to find force, we have to find acceleration. So we're going to use this information to find the acceleration using this equation. A equals VF minus VI divided by T. Alright? We don't have to do any algebra, it's already solved there. So, if I just go ahead and plug in numbers, my acceleration is my final velocity, 0.30 meters per second, minus my initial velocity, which is 0 meters per second, all divided by my time, 0.75 seconds. So you're simply going to do that. Now, we're going to do 0.3 divided by 0.75 equals 0.4. So my acceleration is 0.4, 2 sig figs, 2 sig figs, so 2 sig figs, 0.40 meters per second squared. That's my acceleration. So then we have to use that acceleration to find the force, because F equals m times a. Now in this case, the mass is the combined mass of both of those, because she's in the boat, so she's pushing both of them. So our combined mass is 27 plus 52, which is 79. So our total mass is 79 kilograms, and our acceleration is 0.40 meters per second squared. So the force is our 0.4 times 79 equals 31.6, but to 2 sig figs comes out to be 32 newtons.